Good morning, class. So we are going to try something a little bit different today. I am going to be giving you a short video of the purpose of today's lesson, and then you're going to do your work independently and then complete the cool down. So the first thing we're going to do is we're going to look at our digital notebook to review some of our vocabulary and the terms that we've already talked about. So I'm going to click our digital notebook here. And then I'm going to choose this tab down here to go to Unit 1, because that's the unit that we're in. So we've already talked about area, compose, decompose. But today we're going to be talking about parallelograms. Now, one of the biggest things that you can see about parallelograms, they are made of four-sided polygons with two sets of parallel lines. So when we see our polygons here, we can see that each set are parallel and the lines are the same. So that's going to be the same height on this side and this side and this side and this side. Same thing here when our other shapes. These are all parallelograms, even though they look a little different. So those are a couple of the key things to remember when we're talking about our parallelograms. Now I am going to go back to Canvas, and we're going to look at a couple of these applets that we have for today. So I want you guys to go through and play around with these and look and see exactly the things that you can do with our parallelograms. So as you can see right here, our parallelogram looks kind of like a rectangle or a square that has been tilted to its side. But as you can see right here, just like we talked about the other day, what I can do is I can just adjust and draw a line right there, and now I have made myself a triangle. I'm going to do that again, pardon my crooked line. But I have made myself two triangles on each side, okay? Go back and reset that. So you can see here, some of these triangles will fit right in there. So I am left with two triangles, and then I'm also left with a rectangle in the middle. So all those things we can think about when we're trying to figure out the surface area of a particular parallelogram. So I can show you that all three of those shapes fit into that one parallelogram. Well, what happens if I choose to rearrange some of these? Let me grab this triangle and grab this triangle. Now I have made a rectangle. And it just so happens that that is the exact same size as this first rectangle. And it happens that I know that all three of these shapes were the ones that fit into this first parallelogram. Well, if I decomposed it and rearranged it, I could move that right here. Now, rather than the original parallelogram, I just have one rectangle. And I can also show you that that happens to fit this shape right here. So if I was to quote-unquote untilt this parallelogram, it would actually take up the size of this green rectangle down here at the bottom. Okay, that's just one of the cool things that I wanted to show you about that. Now I'm going to go to the other applet and show you one more thing. Now, same thing applies here. I can drag these, the same shape of parallelogram. I can drag that one there, and then this one here, and then I can drag this one right there, and that would all be the same. The other box that we didn't show you in the first one is this blue box. The blue box, you will see that it would actually take up the space of the whole outside. Now, that is not what's contained on the inside of the parallelogram, but it's all the space that it touches from one corner to the other corner, okay? So that's not especially needed at the moment, but I just wanted to share so you guys could see how it works. Now, as you can also see, depending on if I change the shape of the parallelogram, some of the other shapes that go inside of it change as well. So if I adjusted the shape of that parallelogram, well, now I've still got my two triangles that will fit in there, but my rectangle that goes in the center is much smaller, okay? Or if I change my parallelogram to where it's wider, well, now all the other shapes had to grow to accommodate what was inside. Okay? I'm going to move this one out. And then lastly, I wanted to show you guys how if, again, this blue one is the exact shape of the exact space of this parallelogram. If I change the corner of this parallelogram so it's no longer at an angle, well, look at that. I have no triangles that would fit in the sides. So this is just something kind of cool to help you visually see how adjusting the shape of the parallelogram can change the different shapes that can fit into it when I want to decompose and then recompose shapes that fit inside. All of these are just different ways that we can represent how that particular shape is made and how we're going to calculate the area of it. All right. So now that we've gone through those and talked about the meaning of the parallelograms, what I would like you guys to do is to complete our next assignment for today. So if you go to task and you go to lots of parallelograms, that is going to give you your worksheet for today. And I want you to find the area of the parallelograms. Now remember, you can do this multiple ways. I can change this to where this area right here, this triangle, isn't going to be here anymore. It's actually going to be over here. So rather than having one or two triangles that I have to worry about, I'm just going to move this triangle over here and calculate it that way. If anybody has any questions, please pop back into the Zoom session so we can talk about it. Thank you very much. Please complete your task. Once you are done with this particular task, I also would like for you to complete your cool down. When you are done with your cool down, I need you to log back into Zoom. I need you to let me know in the chat box, okay? Thank you very much. Have a good day.